Alright, so I read a comment on YouTube, and the person wanted to know whether or not tuning to a different hertz frequency would mess up your absolute pitch for standard pitch. And the answer to that is no. The thing is, you can start on any hertz tuning, you can start on any specific frequency and create an octave. And within that space of an octave, you get your 12 divisions in any hertz tuning and any musical temperament. It's just in that space range. So if I were to tune to 400 hertz as my concert A, and I were to play the opening of Tchaikovsky's Fourth Symphony, the A flat would be around 377 hertz. Now 377 hertz is 40 octaves lower than the range of raspberry color in between magenta and red. So doing 400 hertz would make the A flat sound more like a G than an A flat. So here's what it would sound like. So in between that, in between that, in between that octave, like I said, you'll have every hertz tuning and every musical temperament. Now, what if I tuned to 500 hertz? So my A, concert A, is going to be at 500 hertz. That's going to put the A flat at around 471 hertz. Now that's 40 octaves lower than the space range of yellow. So it went from G to B flat. You can still create the same tune. The tuning is just different. The temperament can stay the same, but the hertz tuning has changed. So it really doesn't matter whether or not you call a specific frequency range one color or the next, one note or the next, relatively, but the objective wavelengths of these frequencies will produce a specific color. So you can look out and see all these different shades of orange, but there's a balance. You can perceive a pure orange that's in between a pure yellow and a pure red. Now, that pure balanced orange is just so happens to be 40 octaves at 432 hertz. So that's where the 432 hertz comes from. It's just pure saturated resonances. It gives you your pure colors. You can use 432 as an adult to develop absolute pitch. And then when you go to standard pitch, all you have to do is just make the note 1/3 sharp. If you make the note another third sharp, 2/3 sharp is actually passing the quarter tone and is now 1/3 flat. So you're raising the tone sharp, but not sharp enough to make it flat. So all you have to do is just play everything as sharp as the note will go without changing how you label the note, without changing the range of wavelength. So you have ooh. So, like I said, it doesn't matter which hertz tuning you use or which temperament you use. The space between the octave of any starting frequency is going to give you the 12 divisions of every Hertz tuning and every musical temperament. So all you have to do is compare the space in between the range. Learn the 12 colors, the 3 primary, 3 secondary, and 6 tertiaries. So you have A flat, which is an octave of red. You have C, which is an octave of green, and you have E, which is an octave of violet. So you have the 3 primary colors. Well, science used to say that blue is a primary color, but blue is in between violet and cyan, and they confused aqua for cyan. They really didn't know where that specific frequency range is, just because it's really precise. But cyan is an octave of D. So you have D, F sharp, and B flat as your secondary colors. D is cyan, F sharp is magenta, and B flat is yellow. So it really doesn't matter whether or not you call yellow a blue, like a dark blue. Yellow is always going to be brighter than blue. The wavelength in number, the frequency, is going to be brighter than blue. So you have red, which is warmer than blue, and then you have yellow, which is brighter than blue. Okay? Now, I think I explained that pretty well. Like, if you have any more questions, then you can write it in the comment section, and I'll elaborate more. But you have your 3 primaries, your 3 secondaries, and 6 tertiaries. That's just the 12-tone system. Now, if you use your 36-tone equal temperament, the 36th root of 2, and you start at 440, what you're going to do is you're going to get 3 divisions for each note. So you have sharp, flat, and in tune. And the specific Hertz tunings of these notes, you'll have 432, 440, and 448. So depending on where you call in tune to be, the specific wavelengths of 432, 440, and 448 will have objective visual color associations. And it just so happens that 432 will give you your pure saturated resonances. So it gives you your pure colors. 432 allows you, as an adult, to develop absolute pitch. And then, to master standard pitch, after you've played around with 432, you just, like I said, play the note sharp, but don't play it so sharp that it becomes flat on the next note. So you just keep everything within the range that it's called. So you have F sharp, which is magenta, G, which is raspberry, A flat, which is red, A, which is orange, B flat, which is yellow, B, which is lime, C, which is green, C sharp, which is turquoise, D, which is cyan, E flat, which is blue, E, which is violet, F, which is purple, and F sharp, which is magenta. Now, they used to say that violet was at the top and red was at the bottom. But the thing is, purple's at the top. Purple vibrates faster than violet does, and raspberry vibrates slower than red does. So there's more than just 7 colors. You can use any temperament and any Hertz tuning to get your 12 divisions. Now, 440 is just tertiary. So you're not going to get a pure red, a pure green, or a pure violet, and you're not going to get a pure yellow, a pure cyan, and a pure magenta. So everything's just shifted 1/3 of a note sharp. But like I said, after you've gone 2/3 sharp, you pass that quarter tone and it becomes 1/3 flat. So does that make sense? All right. So you have yellow at. If you were to sing it like that, you would put it in 444 hertz, And many people with absolute pitch do that. They sing slightly sharper than standard pitch, but they put it at that perceptual quarter tone. Now, boo is right in between yellow and lime. But since the B flat in standard pitch is slightly lime anyways, people really don't have this refined perception to be able to make things more specific. So your 444 hertz gives you your quarter tone in 432. So I hope that explains some things and enlightens you on the whole ordeal. And if you have any questions, you want me to elaborate on some things, you can go ahead and type that in the comment section below. Thank you for listening.